So I want to solve this exponential equation. So I consider this equation as a complicated two equal powers. And the reason why I say it's complicated that many people will think about like, okay, their power is equal, let them equate the bases. So which is not true. This is a complex and complicated two equal power, honestly. And at first glance, it looks like there is no solution because the powers are equal, so like this and this. And if you say x equals x minus 1, you transfer this here, so we're going to have a 0 on the other side, so that is 0 equals 1, so which is not true. But if you only find one answer in this kind of equation, you have missed almost 90% of the problem. And I'll just tell you, so we're going to solve it using step-by-step guide. Is how to solve the complex rule to unlock the problem. Let's see solution. So we'll be using two different methods to solve this particular problem. So let's say method 1. So what we have is x raised to the power 10 equals x minus 1 raised to the power 10. And we just need to transfer this to the other side. So we will have x raised to the power 10 minus s minus 1 raised to the power 10 equals 0. So by expressing this as a difference of that square, so that we have, let's say this is equals s raised to the power 5 raised to the power 2 minus, so then we have s minus 1 raised to the power 5 equals 0. So we've expressed this as difference of two square, right? But remember the identity of difference of two square, such that if you have a square minus b square, this is equals a plus b multiplied by a minus b. So applying this to the above expression, so we are going to have s raised to the power 5 plus s minus 1 raised to the power 5, then multiply by s raised to the power 5 minus x minus 1 equals 0. All right, I hope you understand it. Let me know in the comment section. So what we are going to do now is we have two factors there, so but let's first deal with this one. We want to expand this, and by considering this sum of 2/5 power, so let's say we have such an identity of a raised to the power 5 plus b raised to the power 5, right? So we'll be using the identity, we'll be using this identity. One of the factors is this, and we are going to deal with this first. So now if you want to express this, so this will be a plus b a raised to the power 4 minus a raised to the power 3b plus a square b square minus a b raised to the power 3 plus b raised to the power 4. So by applying that, so let's just say we have a, if you want to compare it with that, so we have our a to be x and our b will be s minus 1. So applying it, so we are going to have x plus x, right, minus 1. Then we have x raised to the power 4 minus s raised to the power 3 x minus 1 plus s raised to the power 2 s minus 1 square. All right, so we still have minus, x multiplied by x minus 1 raised to the power 3. All right, so now let's do something here. So we are going to have s raised to power 5 plus x minus 1 raised to power 5. This will be 2x minus 1, right, multiplied by s raised to power 4. If we expand this, we are going to have minus 2x raised to power 3, right, plus, also if you simplify this, you are going to have 4x raised to power 2 minus 3x plus 1, everything equated to be 0. So then what we're going to have here will be, we have one factor here, we equate this one to 0, and we also equate this one to be 0. But let's first deal with this. We have 2x minus 1 equals 0, and what we have here is 2x equals minus 1. Therefore, for this particular factor, we have our x to be equals 1 divided by 2. But let me hold this second factor because I will not be going there next. I'll try to go to expand this particular factor next, so before I come to the other factor below. So like I said, so we look at the second factor. So that is the difference of 2/5, so which is x raised to power 5 minus x minus 1 raised to power 5 equals 0. So however, by using binomial coefficients, so binomial coefficient for 5 will be 1, 5, 10, 10, 5, and 1, right? So therefore, for expansion of x raised to power 5 minus x minus 1 raised to power 5 equals 0, we will have, okay, don't let it equal 0. So we will have x raised to power 5 multiplied by x raised to power 5 minus 10, sorry, so we have 5 next, minus 5 x raised to power 4 plus 10 x raised to power 3, right, minus 10 x raised to power 2 plus 5x minus 1. All right, so now we will have this to be equals 5x raised to power 4 minus 10x raised to power 3 if you simplify, plus, then we have 10x raised to power 2 minus 5x plus 1 equals 0. So solving this will be a little difficult, so we are going to break 10 raised to power x and 10x raised to power 2 into 2. Do you understand? So, and to do that, so we are going to have x raised to power 5 minus x minus 1 raised to power 5. This will be 5x raised to power 4 minus 10x raised to power 3 plus 5x raised to power 2 plus 5x raised to power 2. So that means that we've broken this 10 into 2 now. So then what we are going to have is minus 5x plus 1. All right, so now what is next is to kind of factoring this. We will have this to be equals 5x raised to power 2, then we have x squared minus 2x plus 1 plus 5x, then x minus 1 plus 1, right? But you should know that this particular expression is equals to x minus 1 raised to power 2, right? So therefore we have the expression of this to be equals to 5x squared, then x minus 1 raised to power 2 plus 5x, then x minus 1 plus 1. I hope you understand it. So we're going to factorize something here, so that we have this to be 5, right? So x minus 1 square plus 5 multiplied by x multiplied by x minus 1 plus 1. So from here now, so we can let this s minus 1 to be equals m, so that we have here we have this to be 5m squared plus 5m plus 1 equals 0. So by solving this quadratic equation, we have m to be minus 5 plus or minus square root of 5 divided by 10. Now, instead of trying to plug it into the original problem, so like set x multiplied by x minus 1 and solve for x value. So I tell you that that can be very radical move. You understand? So one of the two factors. So here now we have these factors. So we have two roots here. Meanwhile, we've already gotten one of the roots. So but this is m, right? So that means that we've not gotten our x for this particular one. So like I said, so we can do this. Let's write x multiplied by x minus 1 as x squared minus x equals t, right? So what we have here is x squared minus x minus t equals 0, right? So if you now solve this quadratically, we will have our x to be 1 plus or minus square root of 1 plus 40 divided by 2. This is what we have. So now if t, let me try to clean this and open another page. So now if t equals minus 5 plus or minus square root of 5 divided by 10, so one of the roots, right? So then we are going to find the discriminant. So say 1 plus 40 equals minus 10 plus 4 root 5 divided by 10, and this has a condition that is less than 0, right? So for t, we have minus 5 minus square root of 5 divided by 2, and this implies that we have minus 10 minus 4 root 5 divided by 10 less than 0. So what this means is the solution will be not really complex solution, and therefore what we will have is, don't forget, we've gotten one root to be 1 over 2, right? So and the other one we have 1 over 2 plus or minus square root of 25 minus 10 root 5 high divided by 5. And for this other root, so we have 1 divided by 2 plus or minus square root of 25 plus root 5 divided by 5 high, right? If you look at this, you see how many roots do we have here? We have 4. So this is 2 and this is 2. So we have 4 roots, right? So that gives us 4 solutions. So but don't forget that we have the factor we have not evaluated, and that's one I asked you to keep earlier. So which is x raised to power 4 minus 2x raised to power 3 plus 4x raised to power 2 minus 3x plus 1, right? So if we solve this, we are going to have x equals 1 plus or minus square root of 5 minus 2 root 5 divided by 2i, and for the other one we have our x to be 1 plus or minus square root of 5 plus 2 root 5 high divided by 2. But don't forget, for this particular expression, so we've gotten our other x to be 1 divided by 2, right? So yeah.